Well, g'day, welcome back to another episode in the shop. So, we continue on with the tool post that we machined up in the last episode. So, I think I already mentioned before we have a slot to cut in the top and a couple of mounting holes to go in to mount it to the top of the ball turner. So the slot's straightforward once we have the setup in place, and the mounting holes will drill in from the back because they will cut through this radius on both sides. So I'll swing you around, we'll get it set up. Okay, so I've dug out one of my old 3-jaw chucks, so we'll use that for mounting the part. Now, speaking of this setup, realistically, it's as far as I'm concerned, it's not recommended practice. I should really have this mounted on the rotary table, but I haven't. So, as I still have to make a base plate for this chuck for the rotary table. So what we've got a V block on the rear of it to support it, and we have a little copper shim in front. So that's reasonable secure. We can't put too much pressure on the clamping pressure on the vise because it is a Chinese chuck and it does distort the body of the chuck. You can feel it with the chuck key when you tighten it up. But for what we're going to do to this, it'll be good enough to hold it. Okay, so what we've done, we've gripped our chuck in the vise. We've used we have a long stem Federal test indicator. It has a lot longer stem than your standard one. So we've swept the OD of the chuck, and this is where the long stem one really came into play, because we had to get down above the cranking pinion for the chuck and below the jaw slot. So the standard short stem one indicator of this style was a bit of a handful to get in there, so this came into play really well. So next stage is to mount our part in. We get our chuck key. Okay. So I'm going to put some copper strips under the jaws just to protect the part. It's another one of those operations where 3 hands would be really good, but we're only born with 2. Most of us are only born with 2. Now I just want that very lightly gripped so I can still rotate that. Okay. Now, the other week I had a short one on this chuck keys. See how I bend mine up at an angle? It also allows, doing that, gives really good access when you're in tight spots with your chuck. As it gives, I'll just angle you down a bit. Just gives better clearance for the key, just in these sort of cases. Very rare it happens, but it happens. It's just happened now. Okay, so what we have to do, our axis of the chuck and our axis of the small diameter is directly in line with the axis of the machine. So what we have to do is come we have to move it over our offset distance. So put our indicator on our part, zero our indicator. Now, how we get the distance is we subtract that diameter from that diameter there. So that diameter there is 2.7095, and our smaller diameter is 1.758. So if we subtract those, we get 0.9515. So what we have to do then is halve that distance, becomes 0.4757. Now that's our offset. That's our new offset. Why I say new offset? Because we've polished this in the lathe after our original machining dimensions were established. So that they've changed a couple of thou. Okay, so if we move the table across towards you, 475 thou. We'll make it 475 and a half, because it is supposed to be 4757, so we'll move that across. So we go 100, 200, 300, 400, 450, 460, 475, and a bit over a half a thou, so 4757. So we'll lock our table off. Okay, so then we have to reset. We have to clock up this diameter now. So we'll get rid of this indicator here. And we'll put our last word in. Just got to get it. This is why we've only gripped this loosely in the chuck, because this is the only way we can clock this. We have to move the part by hand. We'll just get our clock in a bit closer. Just a little bit at a time. So we've got 0, 0, minus the thou, and 0. Okay, so we've centralised the larger diameter in line with the axis of the machine. So as I've said before, we've just lightly nipped this in the vise, in the chuck, and we've just lightly manipulated this from side to side by hand, just to get it in the right location. So now when we set up for our holes, our hole centres here, we are exactly perpendicular, 90 degrees, to the offset of this smaller diameter. So we'll tighten the chuck up, which in our indicator didn't move too much. 0, 0, well, we lost half a thou there. 0. And we lost half a thou there, but that's within a thou, that's really good. Okay, so what we have to do is remove this indicator. And we set up an indicator now to offset half the distance of our bolt holes. So our bolt centres are 2.2 inches, so we just offset 1.1 inches. So I'll just put an indicator on here and shift it. Okay, so our indicator's on 0, so we're going to go 1.1 inches across that way. Okay, so we've moved a total of 1 inch 100th thou, and that'll get us in line for our 2.2 inch hole centre. So we'll lock her off. We'll get a slot drill set up and bring you back. Okay, let's push our holes through. Okay, now we'll switch over to our slot drill. Okay, we'll go through with a slot drill now. The reason I've chosen a slot drill for the final hole sizing over a drill is I want a very accurate hole size. That'll help locate the part when it goes on the ball turner attachment. Plus it'll also give us a better, truer hole, because we are breaking through on an angled or a radiused edge on the other side. So we'll just feed this through very gently. Plenty of oil. That's it, we're through. Test fit for our screw. Beautiful, perfect. Okay, we'll move our setup to the other hole and bring you back. Okay, our last hole. Looking good. Okay, we'll countersink that. So drill chuck back in. Small countersink. That's it, complete. Okay, so what I'm going to do is reset this up in the lathe at some stage, because I've changed, well, just doing a bit of a modification on the base where it locates onto the ball turner. I'm just going to bore a small recess in here, probably something about 3/4 diameter, and I'm going to press in a small locating stud so it will locate an exact spot on the ball turner every time. Okay, so we've just machined in an additional feature on the base of our tool post. We've bored this out to 1/2 thou shy of 3/4 of an inch diameter to enable us to press in a 3/4 inch diameter spigot just to help it locate on the rotating assembly. Okay, we've got our tool post set back up in the mill, so we have to machine a flat surface here for our cap screw to pull down onto. Now I'm just going to use just a slot drill for that operation. So to centralise it, I've got an old Ifanger 8mm boring bar, which is a real snug fit in our holes that we cut through with the 8mm slot drill. So we're just using the Blake, and we're just indicating off the diameter of the boring bar, and that will centralise. We just sweep it round. We can't go a full circle, but we can go 3/4 of the way around. And our needle's not moving, so we're on centre. So we'll put our 12mm end mill in. We'll come down, we'll cut these seats flat. Okay, I had to change over to an end mill for this because the slot drill was a bit too short in reach. So I found a longer end mill, so we'll carry on with this and put our seats in. Cover down very gently. We're only cutting on one side. Just till the cutter makes full circle contact, that's all we need. There. Set now 0. Come back up out of it. See how she looks. Well, it looks pretty good from here. Okay, we've got our part reset up in the mill, so we're just setting up for the operation of putting the tool holder groove in, which is in line with the axis of the offset. So we're just referencing off our 2 mounting holes that we have. Now we have our 8mm I-fanger boring bars sitting in there because they're a really neat fit with no clearance. So that's pushed up against this parallel, and we've got the indicator there. We're just indicating off the back of the parallel here. So we'll bring you around. So as long as we're within a thou is fine for this, but bring the needle down. As you can see, the needle's not moving at all, she's rock solid. So we're within the range where we want to be as far as parallel goes. So what we'll do now is we'll set up an indicator into the spindle of the machine, and we'll indicate our axis of this diameter here, direct true to the spindle of the machine, and then we'll put a cutter in and we can offset to the left and right to machine the slot for the tool holder. So we'll bring you back when we've got that part set up. Okay, we're just sweeping in the OD of the part just to give us a central point directly underneath the spindle of the machine. So that gives us a starting point for our offsets for the 2 bolt holes for the clamping screws for the cap, and gives us our centre position which we can work either side of to mill out the keyway for the tool to sit in. So we'll get it clamped up now and get the holes drilled. Okay, this is our plan view looking down on top of the tool holder. So this will be our 5/8 slot. So when we mill this, what we'll do is we'll get our milling cutter, measure the diameter, subtract the diameter of the cutter from the width, 5/8, and whatever that turns out to be, divide that by 2, and that will give us our offset either side of centre to bring the slot to 5/8. And the 2 bolt holes, this one and this one, they're on 1 1/8" centres, so that's just a straightforward 9/16 step over either side of the centre to position them. So because we're already on centre at the moment, it's just travelling backwards and forwards that way to do the bolt holes first, and then we'll re-clamp our part without moving it with the toe clamps on either side, and then cut the slot. Okay, we're all set up now. We'll put our slot in for the tool to sit in. So we've just got a 12mm slot drill, so we'll take it down to depth and then just take a bit off either side to bring it to width. So